We're going to look at a hyperboloid of one sheet. And the equation we're going to start with is x squared over 4 plus y squared over 1 minus z squared over 9 equals 1. And to make sense of these quadratic surfaces, I encourage you to think about the traces. So we're going to start with the xy trace. How does this intersect the xy plane? In that case, z is 0. So we get x squared over 4 plus y squared over 1 plus 0 equals 1. And this is an ellipse. What does that ellipse look like? X goes out to 2, y goes to 1, and this is what will be on the floor, if you will, of this quadratic surface. That's where we'll intersect the xy plane. So we have an ellipse in the xy plane. So why is this called a hyperboloid? What's happening there? Let's look at the xz trace next. If we're in the xz trace, the y goes away, and I have x squared over 4 minus 0 plus 0 minus y z squared over 9 equals 1. So what does this look like? Can you visualize where this is going to intersect at the xz plane? Again, typically this is x, this is y, this is z. So this is where we're looking at that view, looking at the left view of this surface, if you will. What does that look like? Well, that's an ellipse. We recognize that, I hope. So if this is x and this is z, x goes out to 2, z goes up to 3. And these are the asymptotes. And it comes out like that, comes out like that. And x comes first, so the hyperbola is going to look like this in that direction. So in the xz, we're going to see a hyperbola. So can you visualize that? Visualize the ellipse on the floor, if you will. Looking at it from the left side, we are seeing hyperbola. Now, so top view is an ellipse. Left view is a hyperbola. And then we will finish up with the YZ, which is in essence the front view. If we're looking at this straight on based on this coordinate system, that's the front view. If I have the YZ, then the X is 0, and my equation becomes y squared over 1 minus z squared over 9 equals 1. So what does that look like for our hyperboloid of one sheet? Y just goes to 1, z goes to 3. And this is the portion that is going to define my hyperbola. Asymptotes go out to the corners of this little box. Y comes first. Remember, this was the y-axis, this was the z-axis. So this is going to be our front view, is also going to look like a hyperbola. Front view is a hyperbola. Left view is a hyperbola. Top view is an ellipse. So what does this look like? Can you visualize that with those various pieces? Breaking it down to 2 dimensions, can you see what this is going to be? So here is our Desmos graph. X squared over 4 plus y squared over 1 minus z squared over 9 equals 1. Can you see the ellipse in the xy plane? Notice if I spin this thing around, you can see that little ellipse in the xy plane. If I give you the top view and we just look at that, again, you can see that little plane there. You'll notice that the y direction goes to 1 and the x direction goes to 2. So this is not quite what we want. Notice x is to the right here. Now y is up. There we go. So x goes out to 2, y goes up to 1. That is that trace. Now, how about our left and our right view? What is my left view here? What is my right view here? Left and right are the same. I guess I want to talk about what? I want to talk about the left view and the front view. So the front view is here. This is xz, and you can see that hyperbola. The front view from this perspective is xz. I like to have x coming out this way. So in that case, yz would be another view that we have. You can see the yz hyperbola in that plane. You can see the xz hyperbola. Excuse me, this is yz, and this is xz is what I want to say. We see the two hyperbolas, and then you see the ellipse here. And you put those together and you get hyperboloid of one sheet. Now, what I need to know here is what is the axis of symmetry. So notice how this thing is spinning around. The axis of symmetry that this is spinning around is the z-axis. So that is something that I like to say in this situation. So for this hyperboloid of one sheet, the axis of symmetry is the z-axis. So now how would that change if I change the problem? So looking at this, you'll notice I have two positive things and one negative. If instead I make the y the negative and the z the positive, we still have a hyperboloid of one sheet, but the orientation has changed. Yes? And now what is my axis of symmetry? It's wrapping around what? In this case, the axis of symmetry is the y-axis. May I get a better image? Yeah, not really. It all sort of looks the same. So my hyperboloid of one sheet this time has an axis of symmetry as the y-axis, whereas previously, when y was plus and z was minus, the axis of symmetry was the z-axis. So what am I going to have to do to have the axis of symmetry be the x-axis? Again, one minus sign and the other two are positive. So let's make the x the minus. Let's make the other two positive, and I should have the x-axis should be the axis of symmetry, and sure enough, it is. You see x is coming out this way, right? So the whole thing is wrapped around the x-axis. And then you can see, again, what do we have? We have two hyperbolas and one ellipse. The ellipse is in the yz trace. So the yz trace is here. Notice y to the right, z on top. The yz trace is that little ellipse.